This is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and please participate, but please don't share personal information during the class for your own security reasons. So we are in the December 7th attendance ticket. The link is in the chat box along with the password for those of you that are in the live class. Remember, you can't get the password from the recording, so if you're not coming to class, then you are not getting 10% of your grade. You're automatically getting those points docked. So make sure you come into class, make sure you are getting those done. All right, so we only have 22 days left of quarter number 2, so that means we are over halfway through the quarter. It's going to end much quicker than you expect. So today we are doing our midterm exams, since again we are halfway through the quarter. So please go ahead and get your mind ready for that, because that's what we're going to be working on today. It's going to go over everything that we have learned so far in class. So as long as you've been attending class, doing all of your assignments, doing the review days with us, you should be pretty confident about what we're going over in this exam. So at this point, we've already just finished unit number 5, right, talking about elements and the periodic table. So our objective today, though, again, is going to be over all of our units. So our first unit, we talked about matter, atoms, elements, molecules, and the scientific method. We also talked about gas properties, laws, temperature, pressure, and volume. We talked about the difference between physical and chemical properties. We talked about the different states of matter and how phases and energy are related to those. And then again, we just talked about the components of atoms and how atomic mass is related to atoms. All right, so this is everything that our exam is going to go over today. A lot of it should be review and should be familiar because we've already gone over it. Okay, so first things first, let's go ahead and fill out our attendance ticket. Today there's only 2 questions, right? It's going to be this question right here for our attendance ticket, and then you can go ahead and minimize it, and then you'll be working on the midterm exam for most of the class. So the attendance ticket, it's just this question and then the last word at the end of class, but for most of today we're going to actually be working on the midterm. So that being said, I'm going to go ahead and have you guys open up your midterm exam. Let me send you the link to this. All right, again, green checks once you have your midterm exam open. Okay, please be aware the midterm exam is the largest grade in the class. Zoe, it's already there. Just scroll up. It's like 2 links above. Okay, so the midterm exam is the largest grade in the class up to this point. Complete it right away. I will be entering zeros at 4 o'clock, so if you see your grade dip a whole bunch at 4 o'clock, it's because you haven't yet done the exam. Okay, let me go ahead and try it one more time, Zoe. All right, so I'm pasting again. The ticket is in the chat box along with the exam. Yeah, Ariana, I know that your computer goes crazy if you have more than one thing open, so taking pictures is totally fine. So here's what's going to happen today. Please do not take long to answer the questions in the exam. I do give you time after each slide to answer questions. So you get 30 to 60 questions, or sorry, 30 to 60 seconds, depending on how many questions we're answering. That being said, that's not a lot of time, so you either need to answer very quickly or you need to take a picture and give me a green check. Smiley faces if that makes sense. Smiley faces if that makes sense. Smiley faces if that makes sense. Cool. Okay, now what we're going to be doing is we don't have a lot of time. There's 26 questions and there's just not enough time to do every single one. Is anyone else having trouble opening the exam? Demetrius, it might just be your computer. So again, you can take pictures. If you need to, take screenshots or use a camera, a phone camera, and just take pictures of the slides. It'll also be in the recording, right? So just do your best. Yeah, okay, sounds good. So I'm going to be going over the hard questions in class. The easy questions, I will be giving you a recording at the end of class for those easy questions. So there's like 10 easy questions and the video is about 10 minutes long, so it's super easy. It'll make sure that you get every single question done. Thumbs up if you understand. Thumbs up if you understand. Okay, so this is a lot that's going on today. Got to make sure that we are focused and paying attention. Okay, so again, what are the 2 ways that you can do the questions and then give me a green check? What are the 2 options for giving me green checks today when you finish a question? Yeah, either you've taken a picture, a screenshot, right? Or what's the other option? Yeah, just answer it and save it, right? So whichever one you're faster at, go ahead and do that. And then one more time, are we going over every question in class? Are we going over every single question in class? No, which questions are we going over in class? Yes, just the hard questions together. The easy ones will be in a recording at the end of class. Now, that being said, I'm going to be really strict about this today. If you do not give me green checks when I ask you for green checks and I'm sitting around waiting for your green check, I will remove you from the main class. You will be moved to the MIA room. And if you want to get back into the main class, you have to raise your hand so that I know that you're ready to participate. The problem is if I'm waiting for green checks and we're doing such a long exam, if I'm waiting for green checks on one person and they're not answering, then the result is that we don't get done with the exam and everybody suffers, okay? So thumbs up if you understand, thumbs up if you agree, right? If you're walking away from the computer and not paying attention, then you're not going to be in the main class with us. Just for today, okay? Cool. All right, go ahead, please answer question number 1 in your attendance ticket. Give me a green check when you have that saved. Again, this is the first question of the attendance ticket, and then we're going to ignore it and move on to the midterm exam. So green checks once we have number 1 in our attendance ticket open. Saved. Looking good. Waiting on green checks from Angelina, Annalise, and Demetrius, Destiny, Joshua, Kyrie, Kevin, Siva, and Ty. Again, remember, if I'm not getting green checks from you today, you will be removed from the main class because I don't have time to wait for everybody because we will run out of time trying to finish the exam. Here we go. Let's keep going. All right, guys. So we're going to actually start off with question numbers 5 and 6 in the exam. We're skipping some questions and we're going to be jumping around just because some of them are in the recording that I am giving you at the end of class. So we don't need to go over every single one in order. Smiley faces if you understand. Smiley faces if that makes sense. Thank you, thank you, thank you. Love it. Cool. All right, guys. 1 second. I'm just all right, cool. All right, guys. So questions number 5 and 6 are talking about physical versus chemical properties. So physical properties, remember that these do not change the actual chemical makeup of matter. So for example, if we're talking about smell, freezing, boiling, melting, viscosity, density, if we change these things for matter, we're not actually changing the actual molecules, right? It's still going to be H2O, or it's still going to be like H2O. It's still going to be the same exact molecule, okay? So measuring these, changing these doesn't change the identity. So for example, if you freeze water, it's still water. Smiley faces if that makes sense. If you freeze water, it's still water. All right, cool. Now, chemical properties, chemical changes, do in fact change the chemical makeup of matter. So, for example, if something reacts with water, like when we added lithium to water and it began to like fizz around, or when we added cesium to water, it exploded, right? Burning things, these definitely change the chemicals. Zinc added to hydrochloric acid breaks chemical bonds and produces hydrogen gas, which is a new chemical. So all of these things create new chemicals, and therefore they're chemical changes or chemical properties. But remember, in this case, the amount of matter and energy doesn't actually change, just the location of that matter and energy or the type of it, right? So the actual total amount never changes in our universe, just maybe what it looks like or where it is. Okay, so at this point you should be able to answer question numbers 5 and 6. So question number 5 is talking about what is a chemical change. Question number 6 is talking about what happens when bonds are broken and creating new substances. Please answer 5 and 6. Give me a green check when you have that saved. I will be giving you 40 seconds. Ready, set, go. Green checks when you have it saved or you've taken a picture. All right, waiting on a few more green checks. Dalen, Jeremy, Johnny, Melissa, Michael, green checks if we have number 5 and 6 ready in our exam, or you've taken a picture. Taking a picture is fine since I know I'm not giving you a lot of time on every question. Perfect, just waiting on Johnny and Melissa at this time. Remember guys, if I don't get your green checks, then placed in the MIA room. Cool, all right, let's keep on going. All right, oops, sorry guys, hold on 1 second. I don't know why it does that. Awesome, guys. All right, so again, we are skipping around because I will be giving you a video that goes over the easy questions at the end of class. So right now we're going to go ahead and skip over to questions 12 and 10. Smiley faces if you understand, everyone. We are skipping some questions, moving around. Cool. All right. So going down to questions 12 and 10. Now, again, I actually just talked about this, the fact that matter and energy don't magically appear and disappear, right? The law of conservation of energy and of matter says that you cannot make new matter and energy. You cannot delete matter and energy. You cannot destroy it permanently. The only thing that happens is that it may change form or it may change what it looks like, but overall, there's no increase or decrease in the amount. So, for example, when atoms collide with each other, they don't gain or lose energy. Instead, they just transfer it, just kind of like billiard balls. If you ever have played pool, right? It goes from one ball to another ball. The energy just moves or transfers. Smiley faces if that makes sense for number 12 and number 10. Awesome. Okay, at this point, you should be able to answer both of those questions. So question number 10 is asking about what happens when two atoms collide. Question number 12 is talking about the conservation of energy principle. Go ahead and answer those. You guys have 40 seconds. Green checks when you have it saved. Ready, set, go. All right, just waiting on a few more green checks, letting me know that you've answered number 12 and number 10 in your exam. Joshua, Melissa, Seha, and Zoe, green checks. Okay, thank you, Sally, for letting me know. All right, let's keep on going. All right, so we're jumping back now, going to do 8, 9, and then jump forwards a little bit and do number 13. So a bunch of answers on this page here, a bunch of questions. All right, so the properties of solids, liquids, and gases all depend on the motion of their atoms and molecules. So the way that molecules are moving and interacting is really what determines whether or not something is a solid, a liquid, or a gas. The molecule itself does not change, right? H2O will always be H2O, but how it interacts with other H2O molecules will change whether it's a solid, liquid, or a gas. So in solids, those molecules interact by just vibrating in a very rigid structure. So they have a definite shape and a definite volume that does not change, meaning that they stay the same shape and they don't take up more room than what they already have. Okay? Liquids, on the other hand, they're moving a little bit faster. Yeah, Seha, I'll put it in the chat box for you, but right now we're actually working on the final exam. So we're not paying attention to the attendance ticket right now. We're just working on the, midterm exam. Okay? Liquids, on the other hand, are free to move. The molecules can move around, but they do still stay close to each other. So the result is that they don't have a definite shape because they can slide past each other, but they still do have a specific volume, right? 1 cup of water will still be 1 cup of water even if we pour it into another container. Smiley faces if that makes sense. Volume means the amount of space they take up, like 1 cup. Awesome. Now, gases are super interesting because gases can actually pull apart completely. They have enough energy to just move really fast and really far away from each other, and they can move around on their own. So the result is that a gas will try to expand for as much as it can because it can escape, and it's going to try to escape, and it definitely does not have a specific shape. Think about fog, like when you breathe outside on a cold day, it spreads out indefinitely forever, right? So its volume gets bigger and it doesn't have a definite shape. It kind of looks different depending on how you breathe into the air. Smiley faces if that makes sense. Solid, liquid, gas, if all of that makes sense. Now, the way that we get from one state to another state has to do with energy, or thermal energy, heat energy. So heat energy or thermal energy is what's needed to change the molecular movement of these molecules, right? Thermal energy really just means how molecules are moving. So if it has more thermal energy, right, as it gets hotter and hotter, it's going to get into a liquid and then into a gas, right? The molecules will move faster, they'll try to spread out, and the result is they'll spread out into a liquid or they'll spread out even more into a gas. The reverse is also true. If you take away energy, take away thermal energy, they'll begin to slow down, the molecules won't move as fast, they'll come back together, and the result is we end up with liquids and then solids that move even less. Okay, so at this point we should be able to answer number 8, 9, and 13. So 8 is talking about matter that has definite shape and volume. 9 is talking about how ice, we do what, okay? And then number 13 is asking about what thermal energy is, okay? So at this point, I'll give you 60 seconds. Please answer 8, 9, and 13, or take a picture, green checks when you have done one of those actions. Go, go, go. All right, waiting on a few more green checks. Alyssa, Kyrie. Remember, guys, if I see that I'm not getting any green checks from you, keep on going, guys. All right, so here we go. So talking a little bit more about gases in particular, remember we did in fact have an entire unit just on gases. All right, so gases have high thermal energy, so lots of heat. They move randomly and they spread out. They're moving very fast, and as they collide with each other and with the container, this is what creates pressure. Just like you pushing on a door creates force or pressure, the same thing happens with gases. As they push against their container, they create force and pressure, and again, if you get too much force and pressure, you can actually burst open that container. Just like you could push open a door if you add enough force to it. Okay? Now, this is called the kinetic theory of matter. So the kinetic theory of matter states that gas atoms and molecules are very small energetic particles that are bouncing into each other. At high pressure, they're going to have more collisions, right? More collisions. The word collisions literally just means pressure. Yes, one second. We're not doing, actually, sorry, Kevin, we're not even doing the attendance ticket right now. Instead, I need you to have the exam open because we're working on the exam. All right. Okay. So gases at high pressure have more collisions, more pressure, right? At low pressure, the molecules have less collisions. Smiley face if that makes sense. Collisions literally means pressure when we're talking about gases. Okay, now gases, when we want to use gases, we have to store them in a container, which can be very difficult because remember, gases want to spread out, they want to escape. So gases take up a lot of space, so the way that we can get them into a container is by compressing them with a pump, so we can squish them into that container. But this can result in high pressure, and what happens if we put too much pressure into this container? Tell me in the chat box, what happens if I try to add too much gas into a container? Yes, it goes boom, right? It can explode, right? So gases, even though you can't necessarily see gases, gases are still very much there because gases can definitely cause explosions if we don't treat them correctly. Now, the last thing that we learned about gases has to do with air pressure. Remember that the higher up we go into our atmosphere, such as climbing a mountain, is it easier or harder to breathe on a mountain? Is it easier or harder to breathe on a mountain? It's harder, yes. And the reason it's harder is because there's actually less molecules up there. Remember that as you get higher up from the Earth, there's actually less gravity. So since there's less gravity, there's not as much gases being pulled down at the top of our Earth, right, at mountains. And so there's not as many gas molecules, there's less pressure, and therefore it's harder to breathe. So air pressure decreases as altitude increases. As we get higher, we have less molecules, less pressure. Okay, at this point, we should be able to answer 11, 15, and 14. So 11 is talking about what collisions are. Number 15 is talking about what this theory of matter of how small energetic particles are moving around. And question number 14 is talking about altitude. So I'm going to give you 60 seconds to answer all three of those. Give me a green check when you have either answered them or you've taken a picture. Thank you, Mikey. Again, if I'm not getting green checks from you, you will be removed from the classroom. All right, keep on going. 55 seconds. Go, go, go. A few more green checks. Let's see here. Demetrius, Jacob, Kyrie, Kevin. All right, everyone, let's go ahead and keep on moving on. All right, guys, so remember that we've talked about these physical properties of gases: pressure, temperature, and volume, right? So these are all actually related to each other, and if you change one, you actually affect the other ones as well, okay? And this, again, we've talked about this a whole bunch in class. So here are the three properties of gases, right? Pressure is the amount of force that pushes on an area. So again, the collisions that the gas has with the container. Okay, volume is the amount of space that that gas takes up. Okay, and then temperature is the average heat or the kinetic energy of the molecules, right? So faster molecules are going to result in a warmer gas. Smiley faces if that makes sense. These are the different properties of gases. Okay, and again, if we change pressure, it's going to change volume and temperature. If we change temperature, it's going to change volume and pressure, and so on and so forth. They all affect each other. Okay, so let's go ahead and actually apply that. So now we're going to talk about questions number 17 and 16. Okay, so the kinetic theory of matter explains these behaviors of gases. Okay, so again, the kinetic theory of matter is saying that gas molecules are tiny particles moving around at high speeds. So pressure, okay, again, is going to be the total force exerted by those gas molecules as they bump against the container walls. So what happens here is that if you expand the container, then, sorry, if the container, okay, yeah. So here's what's going to happen. If we increase the pressure, right, we speed up those molecules, then if a container can expand, it's actually going to increase the volume of the container, right? Think about in here, all right, ice water versus boiling water. Which molecules are moving faster and having more collisions? The cold ones or the hot ones? Which ones are moving faster and having more collisions? Tell me in the chat box. Yeah, the hot ones are moving faster, having more collisions, and because of that, they're expanding the balloon, right? Since the balloon can get bigger to accommodate that increase in pressure, it's going to blow up even more. Okay, so increasing temperature increases a volume's container or pressure, a container's pressure or volume, depending on whether or not it can expand. Okay, so let's see here. Question number 17 is talking about temperature and volume. And then question number 16 is talking about pressure and volume. All right, so go ahead, please answer number 17 and 16. Give me a green check when you have those saved. You have 40 seconds. Either save them or take a picture. Green checks needed from everybody. Go, go, go. All right, waiting on a few more green checks, telling me you have either saved number 17 and 16 or you have taken a picture of this lesson slide. Awesome. Waiting on Angelina, Jacob, Jeremy, and Ty. Green checks, please. Jacob and Ty. Let's go, let's go. Green checks. Awesome. Thank you, Jacob. Ty, just waiting on you. You're my last person, Ty. Green check for number 17 and 16 or having taken a picture of the slide. Thank you. All right, moving on, everyone. Okay, number 18 is talking about gases and buoyancy. So changing the gas's volume can actually change its buoyancy or how well it floats, really changing its density, right? So if we compress a gas, meaning we push more gas into a scuba tank, for example, pushing more gas into there results in many more gas molecules in that small space. So really, you're making that small space much heavier. Smiley faces if that makes sense. Okay, you're stuffing a lot more gas into a small space. So this makes that small space heavier, which means its density is increasing, which if you increase the density of a gas in a scuba tank, this would allow our diver to sink, right? Because they become less buoyant, less floaty. The opposite is then true, that if you decompress a gas, take away the density of the molecules and let them spread out more, then they're going to be less dense and float more because they'll be more buoyant, more floaty. Okay, this is number 18 in your exam. Let me go ahead and take a look at number 18. 18 talks about decompression, what happens when decompression occurs. Go ahead, answer number 18. You have 30 seconds. Ready, set, go. Green checks, everyone. All right, just waiting on a few more green checks. Demetrius, Jasmine Z. Awesome, cool. All right, let's keep on going. All right, so questions number 25, 24, and 26 all have to do with the nucleus. So the particles in the nucleus are what are called nucleons, and there's only two particles in the nucleus, protons and neutrons. So technically, protons and neutrons are both called nucleons. Smiley faces if that makes sense. That's like the group that they're a part of. They're part of the nucleon group, okay? Now, they both have really important roles. Remember, protons are in charge of the identity of an atom. However, protons are all positives, and when you have all like charges, what do like charges do? Tell me in the chat box, what do like charges do? Like charges do. Opposites attract, but likes do what? Awesome. Yeah, they're going to split apart. They're going to repel. Opposites will repel. So protons, if you only had protons in the nucleus, our nucleus would fall apart because they would all repel from each other. So instead what happens is we add in some neutrons, which are neutrally charged, and these act like buffers between the protons. So they help keep protons far enough apart that they aren't going to repel each other. Now, if you go even deeper into what makes up protons and neutrons, which are called quarks, this helps explain this even better. So protons and neutrons are each individually made up of quarks as well, right? These are fundamental particles of matter. So protons are made up of 2 up quarks and 1 down quark, and neutrons are made up of 1 up quark and 2 down quarks. And here's the thing, guys. Up quarks are positively charged, down quarks are negatively charged, And again, we know that opposites attract. So really what's happening here is that the up quarks in the protons are being attracted to the down quarks in the neutrons, and vice versa. Smiley faces if that makes sense. So the actual individual quarks are being attracted between these particles, and this is actually what's holding our nucleus together. So this is what's called the strong nuclear force, and it is the strongest force in our universe, hence why we call it strong, because scientists aren't super creative, and so we just called it the strong force. Okay, so at this point we should be able to answer question, sorry, one second, oh my gosh. Perfect. All right, so we should be able to answer question number 25, which is asking about what the atomic nucleus is made of. Number 24, which is talking about the fundamental particles that make up protons and neutrons. And number 26, which is talking about how the nucleus is being held together. Go ahead and answer those. You have 1 minute to either answer them and save them, or to take a picture of the slide. I do need green checks from everybody, though. Go, go, go. Looking good. Just waiting on a few more green checks. Dalen, Joshua, Josh, Kevin, Melissa. All right, let's keep on going. All right, guys, so here was our objective today, right? Being able to do all of these things, talk about matter, atoms, elements, molecules, gases, physical versus chemical, states of matter, the components of atoms. Smiley faces if you guys felt good about that, if you feel like you did really well on all of those hard questions, those 16 hard questions. Awesome, looking good, looking good. Yeah, right? That was super not bad, right? Definitely not bad. Awesome. Okay, guys, so here's what's going to happen. I'm going to send you a video right now, and the video link is going to be used to answer the easy questions. All right, so I'm going to go ahead and send you the link to the easy questions. Okay, right here. Okay, go ahead and let me know, give me a green check when you have the link either open or saved, so that you guys can go ahead and answer the easy questions once we log out of class. Okay, this should be, yeah, no worries, Ariana. Yeah, if you can just copy it maybe, and then just paste it into, like Control-C, right? Control-C, and then Control-V will copy and paste it into a document. That way you have it saved. Cool. Green checks, guys, once you have the YouTube video. I will include it in the 5C recording as well, but for now, if you want to be able to do the exam now, which would make sense, use 10 minutes to finish the exam now, go ahead and grab that link. Cool. Perfect. Waiting on a few more green checks. Green checks once you have the YouTube video. Good, good. Red X's if you're having any trouble opening that or getting that copied and saved. Cool. Love it. Awesome, guys. All right, what do you think? Do you guys feel comfortable with doing the remaining questions? YouTube video? Yeah, exactly, Tucker. They're super easy, so you guys should definitely feel really good with them. And it's a short video. It's 10 minutes. Do it right now. That way you don't have to think about it later. Okay, you definitely want to get it done right away. That way you get your grade and you don't see a 0 in your grade book later for this really huge assignment. Cool, awesome, Juliana. That's Hello students, this is the easy questions for the midterm exam, the 5C midterm exam. So let's go ahead and start going over these questions. Again, the hard questions have already been answered during the live class or during the recording from the live class. So reviewing matter, atoms, elements, and molecules. Remember, matter is anything that has mass. All matter is made up of these tiny building blocks called atoms. So atoms are these really small building blocks. You can't go any smaller than an atom and still keep its identity, right? Now, if you take many of the same type of atoms, so for example, many gold atoms, put them together, that's what's called an element. An element is a pure substance that you cannot separate physically or chemically because it's just made up of one type of atom, right? You can't break it down into anything simpler. Okay, so at this point, you should be able to answer question number 1, talking about what matter is. Question number 3, talking about a substance that cannot be separated physically or chemically. And question number 4, talking about what it means if something can't be separated physically. All right, so go ahead, answers 1, 3, 4, and then go ahead and continue playing the video. Okay, so the next question is talking about the differences between chemical and physical changes, specifically talking about physical changes. So physical changes mean that matter changes without actually creating new substances. So the actual chemicals all stay the same. It's just that physically it might be changing a little bit. So for example, if you add energy to crush a pile of rocks, the powdered rock is still made of rock. So even though its shape and its texture are different, the actual chemicals in the rock, the arrangement of atoms are exactly the same. So this has to do with, for example, phase changes, which is going from solid, liquid to gas. With water, liquid water, ice water like icebergs, and gaseous water like clouds or steam. These may all look different, but because they're all made of the same water, the same H2O, these are actually just physical changes. So that should help you answer question number 7, talking about the difference between physical and chemical changes. Go ahead, pause the video, answer this question, and then continue playing. The next question is talking about matter and atoms. So we're skipping down to question 19. Again, all of those hard questions we've already answered in class, so we are skipping around here. So again, matter, anything made up of mass, made up of those building blocks called atoms. Elements are made up of the same type of atom. Now specifically, when we talk about the atom is the smallest unit that still keeps its identity, right? So we talked about earlier, if we tried to split a gold atom into something smaller, it would no longer be gold, and therefore it is not the building block of matter, because anything smaller loses its identity. Okay, so the atom is the smallest thing that does keep its identity. Please answer question number 19, pause the video, and then continue playing when you are ready. Question number 23 is talking about the atomic models and science. Oops, sorry, let me go back up to that. All right, so skipping down to question number 23. So there are a lot of different models that we learned about. The atomic models are important because they allow us to describe the behavior of atoms. And the reason that we need models is because atoms are too tiny, so we can't actually take a photo of them because we've never been able to actually see them. So it's important to have models so that we can kind of understand what an atom might actually look like. Remember, we started out with this atom that was just a solid sphere. That was Dalton's model. From there, we decided that the model was a giant sphere of positive charge with little raisins or pieces of negative electrons studded throughout it. That was the Thomson model, or the plum pudding, or the raisin bread model. Rutherford consolidated all of the mass, which was the protons and neutrons, into the very center of the atom, which he was the one that pioneered the idea of the nucleus, this very dense part of our atom. And then the Bohr model put the electrons in specific areas around the nucleus. So they exist at certain energy levels around the nucleus, which we call orbits or shells. And then the most recent model is a little bit, it looks similar to Bohr's, but in reality, electrons are impossible to know where they are at any given time. So all we can show is their most likely location. So based on the probability model of where they are most likely, we see this kind of fuzzy cloud around our nucleus, and that is what is called the electron cloud model. All right, so at this point you should be able to answer question number 23, talking about where those electrons have been. Go ahead and pause the video, answer 23, and then continue going. All right, so the next 3 questions we're answering 20, 21, and 2, so you will be moving around in the exam right now, is all about the atom. So atoms have 3 parts. Remember, they have positive protons, which are in charge of the atom's identity. And if you see on the periodic table the number on top of each of those squares, that's called the atomic number. The atomic number gives you the number of protons, or the atom's identity. So for example, oxygen always has an atomic number of 8 because it always has 8 protons. Neutrons are neutral, and their purpose is to prevent protons from repelling inside of our nucleus, because remember, our nucleus, if it's only made up of positive protons, it will split apart from itself. So the neutrons are there to act as a buffer, neutrally charged, keeping those protons from repelling. Electrons are negatively charged, and remember, they're on the outside of our atom, and because they're on the outside, just like you would hold hands with somebody and not shoulders with somebody because your hands are further out from your body, the electrons are therefore the furthest out particles, and so they can be involved in bonding or joining hands with other atoms. Now, in terms of size, remember all of our mass is concentrated in our nucleus, so only protons and neutrons really have mass. They each weigh 1 AMU. So for example, you see 3 protons, 4 neutrons here. That would be a mass of 7 AMUs in total. And electrons are so very tiny that we basically don't count them as having mass. So they have negligible mass, meaning almost 0 AMUs. We don't really count it when we talk about atomic mass. You can see that right here. Again, atomic mass is going to be the sum of the proton mass and neutron mass, again, only found in the nucleus. Protons, neutrons, again, they're in the nucleus. Most of the atom is actually empty space. So the nucleus is this very tiny, dense part inside of the center of the atom. But the rest of the atom is actually mostly empty space with these very, very extremely small electrons just kind of orbiting around that nucleus far out of the atom. And again, most of the atom is actually empty space. So at this point, you should be able to answer question number 20. Which is talking about which particle has a negative charge. Number 21, which is talking about what atomic mass is. And question number 2, which is asking about the statement that best describes electrons. Go ahead, pause the video, answer those 3 questions, and then let's continue going. Actually, okay, so here we have the very last question that we will be going over, the very last easy question. This is question number 22. So remember that protons are in charge of identity. So if you change the number of protons, you do in fact change the element completely. It's a completely different type of element, completely different identity. So for example, you can see here hydrogen always has 1 proton. Helium always has 2 protons, and that proton makes a very big difference in terms of identity, right? We talked about how both of these could be used to fill up balloons, but we actually don't use hydrogen because hydrogen is actually flammable and can explode if you if it gets lit on fire, right? Which was a disaster that we talked about in history within our class. Helium, on the other hand, is non-flammable. Remember that extra proton makes a big difference. It's an inert gas, and as a result, it is good for blowing up children's balloons, unlike hydrogen. Now, on the other hand, you can change the amount of neutrons, and this won't change the identity of the element, right? So if we have a hydrogen atom and we start adding a bunch of neutrons to it, it will still be hydrogen because neutrons have no effect on identity. The only thing that they do change is the atomic mass, because remember, neutrons do have mass. They each weigh 1 AMU, 1 atomic mass unit. Now, this is what's called an isotope. So an isotope is a variation of an element based on different atomic masses because of their number of neutrons. So for example, you can see here that all of these 3 atoms, these 3 elements, are all hydrogen, H for hydrogen, because they all have 1 proton, right? Their atomic number, their number of protons is all 1, and that means no matter what, these will always be hydrogen. But their atomic mass is in fact changing because you can see we're adding protons. This one has we're adding neutrons. This one has 0 neutrons, so 0 plus 1 proton equals 1 atomic mass unit. Over here we've got 1 neutron. 1 plus 1 gives us 2 atomic mass units. And over here we've got 2 neutrons. 2 neutrons plus 1 proton gives us an atomic mass of 3. So again, they're all technically hydrogen because they all have 1 proton, their atomic number is 1, but again, their atomic mass is changing, and therefore these are all what we call isotopes of hydrogen, different types of hydrogens based on their masses. That's all we have. At this point, you should have answered every single question in the entire exam, jumping around. We did the hard questions in class, the easy questions in this recording. Thanks so much, and I will see you all later. Great. All right, here's your last word. Thanks so much, everyone, and I will see you later. Bye, everyone.